So we will have this course CS 102 after 101, and our, as you can see, book is going to be Lewis and Loftus' book. We will not cover some parts of the book, but we're going to at least do a brief introduction from those chapters as well. I will briefly discuss what are the contents and what has been covered in CS 101 before. So this course aims to undertake a real-world design task. We're going to achieve this by having you do a project on a certain topic that you choose as a group. So as a member of a group, you're going to work in team and try to come up with a good design and then implement it afterwards as a good software solution. So by doing this as a group, you're going to practice more and more communication and oral skills, and also learn, in addition to doing this project, you will also have learning experience on more programming topics, and also we will practice independent learning. So in general, we're going to transform the basic computer knowledge that you gain in CS 101 and put it into action to gain and implement a new design on your own as a group. And also we will expand the knowledge, the programming experience you had so far in CS 101 onto new topics, including more advanced object-oriented programming and other abstract data types and other implementation details of Java in general. So the topics that we're going to cover in general are listed here. So we will go into recursion, deal with files, how to open a file, read a file, write a file, input-output operations using files. And also we will go into some basic data structures such as trees, queues, and related data structures. And we will go into details of object-oriented programming. We just briefly touched in CS 101 onto the topics of how to design a class and what are the methods. If you remember, we dealt with class hierarchies and how to define objects and access them, accessors, mutators, and copy constructors, and all those object-oriented programming details in Java. And also we will go into event-driven architectures, such as, for example, on a screen that, for example, a user touches the left mouse button, what's going to happen with that action, so that you will detect that event and then drive it to a certain action so that you achieve, let's say, if a left mouse click is going to open a dialog box, you're going to do that, and things like those. And also we will deal with searching and sorting algorithms. If you remember, we had insertion sort in CS 101. We are going to expand our sorting algorithm spectrum, and we will implement additional sorting algorithms, and we will see which one is better than the other one in what senses. So we will see a detailed analysis of those topics. So the project, as I said at the beginning, is going to be a commercial quality program. So you're going to, as a group, choose a topic that you would like to implement a real-life problem, tackle a real-life problem, and implement it in Java. So this is going to have a lot of documentation involved in, because in an engineering work you have to write lots of documents. When you graduate, you will see that for an engineer, if you work for a intermediate or a big company, most of the engineer's time, at least 50% of the time, you will spend on documenting what you have done and what you have achieved. So that's going to be involved in this class as well. So you will have to write as a group project reports indicating, for example, the preliminary design report, what you're going to do, how you're going to achieve, what are the steps, and then you will have design reports as you go all the way in the project implementation. And we will also implement whatever you report. You're going to implement that. Obviously, it should be a bug-free and easy-to-use application that you're designing. Otherwise, it's not going to be useful for the user, right? If you do not have a user-friendly application. And we will, again, it's going to be a group project, so you have to, behave according to a group mentality. So you have to be part of a group and responsible what you are supposed to do, and you will need to fulfill those tasks. And we will have presentations and reports dealing with this project. So it's, you know, on top of what we're going to cover in the course in terms of new topics, we will also be dealing with the project to, you know, complement what you have learned on real life problem. So these are the two main, you know, parts of the course. As I said earlier, the textbook is Lewis and Loftus, which is, you know, the slides are also available on our website. I will update that shortly, and you will be able to have a link on all the details of the course there too. So the course rules, it's strongly recommended and actually mandatory to attend the course, and if you do not attend below a certain level that we are going to set, you will not be able to pass the course. So be careful on that, and not only passing, also it involves in learning the topic by attending the course. So I strongly recommend you to attend the course so that you will be able to, you know, follow the topics and do whatever it needs to do. So the grading criteria is going to be composed of these parts. So we will have a midterm, final, and again the project, as you can see, has a big bulk of the overall grade, and also the lab work that we're going to start from next week. So there won't be any labs this week, but we will start having our labs next week. So there are going to be 5 or 6 labs, which is also going to deal with the project. So you are supposed to select your group members from the same lab section that you're in with. So your group for the project needs to be from the same section as in your lab. So that's important for us, because we are going to deal with some parts of the project in the lab. So you will have to design some parts of it during the lab, so that you will be in the same groups, in the same sections with the same group members. Another rule is that you have to get at least 30% from the final and the project in order to pass, because we see those two parameters as the metric for you to be able to, you know, at least know some material from the course in order to pass. Even though if you get a you know, good average, let's say 50, 60, if you do not collect these points, you won't be able to pass the course. So this is a minimum threshold we set for the, you know, for the summer CS 102 class. Again, attendance to the lectures and labs are mandatory, so you're supposed to be there at all times, and we will usually set a limit. It's not known at the moment, but we'll probably somewhere around 20-25% tolerance may be there, but it's not for sure. So you're supposed to be here at all times. And also, if you do not attend one of the labs, more than one of the labs, you will fail the course again, obviously without a medical reason or a report or something like that. So you have to have a valid reason not to attend more than one lab. You can miss one lab, but more than that will cause you to fail the course. And again, at the beginning of the course, let me repeat it again, there's not going to be any change in the policy, so don't come afterwards asking for, hey, this happened, that happened, I couldn't attend the lab, I couldn't attend the classes, and so on and so forth. So start at the beginning to, you know, attend the classes and labs regularly. You will fail otherwise. So what has been covered in CS1? Any questions about the rules? Any question about anything so far? Okay. So what has been covered in CS 101, I'm just going to grasp what we have done there, and you know, we will go forward from there. So if you remember, we did you know, how the computer actually processes and implements, you know, algorithms, and how does it actually execute them and run them in the real-time environment. So these involved, if you remember, what are the different hardware components, how do they interact one another. You know, as you know, we use numerical binary, you know, decision mechanisms in computers. So we talked about that, how they operate. For example, how do we store text in the computer and things like those. We briefly touched how this overall computer framework works. And then we go into syntax and semantics of Java, if you remember. So what we did there was how you can write a program starting from the basics, just the skeleton of a program. How do you define identifiers? How do you do assignments? How do you do manipulation on data? How do you take console input output? And also we did deal with string class and how do you print out on the screen and things like those. So precedence rules, for example, how does it operate from left-hand side to right-hand side? How does it assign the values and so on? And also we go into, in order to write programs, obviously you need to have control statements such as, if, then else, switch. And to use these, to utilize these, you need to have the Boolean expressions, right? In order to come up with some logical expressions, you need to have Boolean expressions. And we dealt with that also throughout the CS101 course. And also, without loops, you won't be able to write any program, almost any program. And also, in any commercial product we are using currently, you see a lot of loops being used because if you're accessing data, if you're reading, writing, checking data, then you have to have loops because you usually start from a certain value and continue. For example, an array of elements, you start processing them and then go one by one. So you need to have a loop there, and otherwise you won't be able to implement it. So if you remember, one of the things that we touched is the classes and objects and how they operate. So if you remember, we have instance variables and how to access them and access the methods that are going to manipulate the instance data of the objects that we define. Public-private differences. What's the difference between public variables, private variables? Why do you use private variables and private methods as well if you have to have? And also we talked about constructors. So you have to have an object constructor, the default constructor, and possibly other constructors to create. For example, if you remember the date example we were doing in CS101, you have a date class that you are going to initialize. Constructor will obviously need to take a certain value to start with. You can start with an empty constructor that doesn't have any value in the date, or you could have, for example, if let's say I had a date that is expressed using both day, right, and then you have a month and you have a year component within your date class, then you have to either set all these values without nothing, or you can assign them certain initial values as a constructor, as you have seen before. Also, we had copy constructors, if you remember. So if you have a certain object that you would like to copy the values onto, you can use this copy constructor and copy it. Accessors, you access the values that are actually private within the class, but you would like the users to be able to access them. You will use the accessors. Mutators, if you remember, what are those? Those are the set methods which you modify the internal variables of a given class which are private, which you normally don't touch. However, you touch it by using the mutators. So these are the things that we covered, the basics of the classes. Static methods and variables, if you recall. So how you can declare a static method, why is it useful, where we use it, and so on and so forth. And also we considered, memory and references. If you remember, we had, if you copy a certain class object, how are you going to copy? We had two options, deep and shallow copy, if you remember. Deep copy is going to create a copy that is separate from the actual object that you're copying from, right? So just to remind you, let's say this is an object that I'm referring by my variable A. In the deep copy, what do? You create a separate object, such as B, let's say, and then you copy all the values of this onto this one, but it's a totally separate copy. However, in shallow copy, if you remember, what happens is that you do not actually copy the whole thing, but refer to this same object. Whenever you update this, you also update the other one. So this was the distinction between shallow and deep copy and memory. How do you operate on objects is important to deal with. So we're going to use that information that we gathered so far in CS101 on using the topics that we will cover in CS102. And it will be really useful to, if you do not really know and understand the topics that was covered in CS101, I strongly recommend you to go back and do a review, understand what was missing, in terms of your understanding, and if there's any, lack on yourself, then you should go and read and review the topics that is covered in CS 101, because this is going to build upon that, and you will have to understand the basic material to progress and to go forward. So if you remember, we also talked about arrays. As I said, with loops, arrays are the basic data types that we use in any programming language. So you have to have arrays in order to implement things in real life problems. So we talked about creating and accessing these arrays, how to find out the length of an array, bounds of an array. This is important, right? If you go beyond the bound of an array, you will have a problem. So for example, if I have an array that is, let's say I have an array that has 10 entries in it, 10 integer entries, for example. If I would like to access this array and I try to access A10, what's going to happen? If I have 10 entries in this array and I'm trying to access A10, you're going to get an out of bounds exception error, right? Because since it is 10 entries inside, you will start with entry 0 and then you go all the way to the 9th one, so that it makes 10 elements in total whenever you create it. If you try to access the A10 entry which does not exist, you will face a index out of bounds exception, an error which is going to create a problem. So you have to be careful with the bounds of array. Multi-dimensional arrays, if you remember, we instead of going in one dimension, what you could do is you can have a two-dimensional, three-dimensional, n-dimensional for that matter, array which is composed of, for example, in this case I have a two-dimensional array and I have n rows and then m columns. Let's say I would like to access this entry here that is expressed in the ith row and the jth column. So what am I going to do is I will access it by saying ai, the row, and then the column j. So this is going to point me to the right exact point where this data is located, and I will be able to access it. So usually arrays come along with loops. So whenever you need to access and process arrays, even if it's a multi-dimensional array, you'll need to use loops to implement that. So for example, for this, let's say for this array, I would like to print this on the screen. What am I going to use to print the entries of an array, such as this one? If I'd like to print this on the screen, all entries of this array A, with n rows and m columns. Obviously, as I said, you will need to use a loop, right? So I will need to use nested loop to capture both dimensions. One is the rows and the other one is the columns. So I will need to implement both of those dimensions. So I will start int I equals 0, right? And then I will have I less than, I'm going on the rows, n. And then every time I will have I plus plus. And I will have for int j equals 0, j less than m, since I have m columns, and then I will say j plus plus, and I will access my element. I'm skipping the system out print line part, so you can fill that part in, and you will just say aij to access this multi-dimensional array and print that on the screen. So this way you will be able to print all the elements of an array. So usually, again, if you have a two-dimensional array, you will need two for loops. If I had three-dimensional array, I would probably have another loop to indicate the next dimension I have. Okay? Any question? So multi-dimensional arrays is again an important topic that we covered in CS 101. And rect arrays. What was rect arrays? If you recall, in regular arrays that you declare, what you have is a rectangle like this, as in this case n by m. However, if I have a rect array, what is going to happen is that instead of a rectangle shape, I will have something like this. So you can have, in each row you can have different length, different number of columns. This way, instead of keeping the whole space without not using them, you can allocate whatever is required only for these, for these rows individually. However, this also has an overhead. You have to declare these one by one and, come up with, create them individually. However, in a regular array, you can declare it at once easily. So it has a storage benefit as opposed to, declaring it in a harder way. Any question? So enumerated types, we covered this also. And enumerated types, if you remember, you declare your own data types such as integer, char, or things like those. You define your own type by assigning different names onto it, and so that the user will not be able to enter the wrong value to the enumerated type data. Such as, if you remember, we had this example, workday example, which was composed of, I'm not going to write the other part again. So you have Monday, Tuesday, and so on. So you define the values that this enumerated type can take, and the values are, in this case, Monday, Tuesday, and so on. So you have to have one of those values in order to assign it. And we talked about array list or generics in general. As an extension to arrays, we talked about this array list concept, which is just an extension to array where you can actually where you do not need to actually indicate the size of the array that you would like to create. However, the array list or Java automatically allocates the space that is needed for you as it gets larger. So it squeezes them down if the data is deleted, and it gets larger if you add additional elements to your arrays. So that was array list that was covered in CS 101. So what are we going to cover in this course? What we are going to cover is that we will go beyond what was covered in CS 101 in terms of classes and objects, declarations, their definitions, method writings, and additional things that we are going to cover will be mostly part of the object-oriented programming methodology. So we will have objects, how to define them, just a brief introduction, and then we will see UML diagrams. UML diagrams are diagrams which indicate the relationship between the objects. So let's say I have an object that I'm using for a certain purpose, then let me write it here. So let's say I have an object that I'm using for implementing another object. So this is the relationship. Let's say I'm using person class object, person class's properties on a student, right? So student is a person. They have a relationship, so every student will have whatever a person has in terms of properties. For example, a person has a name, person has an, let's say, ID, and also, let's say, birth date or date of birth. Let's say you have additional things on person class, and on top of that, for a student, for example, obviously, since he or she is a person, these properties will match for that student. However, on top of that, student has additional properties such as, let's say, GPA, and then let's say you have a list of courses that he or she is taking courses, and so on. So you can use the properties of this person class on this student. So this is called inheritance, actually. So you inherit the properties of person and use them in student. I will go into that shortly. And this way, the UML diagrams are useful in the sense that you can, create any kind of relationship between these classes. For example, person, teacher may be also person. So you have your teacher class, which is going to have certain additional properties, the courses given, the advisees, and so on and so forth. So you can have additional properties that are coming with the teacher, which does not exist in a person class. Right? So this UML diagram is going to express these, and in your project reports we will ask you to draw and write whatever your class hierarchy and relationship is. Okay? So that's going to be part of your design report. And encapsulation, if you're, what does encapsulation mean? Any idea? So it's like you encapsulate your class, cover it up, and it is going to only allow the outside world to see what you let them see. So let's say this is your class. Let's say I have a class A, so I encapsulate it such that I can only give as an output, as a data, a certain thing that I'm letting the outside world see, and then I'm taking in the input that I'm allowing the outside world to give me as an input. So this is in general called encapsulation, and even if people try to modify it, the classes or methods that do not have the right to modify it will not be able to modify it. So that's encapsulation, and we encapsulate it from the outside world. Also, it allows you to modify it internally without ruining this. So you have input and output that is already defined. However you implement inside is a matter of your design. So it doesn't matter for the outside world to know how this is achieved, but what at the end they know is that, hey, if I give this, if I access this method, it is going to return me this value, this result at the end. So internal implementation is up to you, up to the classes, definitions, and designs. How to determine the classes and objects that are needed for a program. So let's say you would like to write a program, but you have to identify what are the objects that you're going to design. For example, let's say you would like to create a student system that every student will be able to access and see their grades and things like those. So how are you going to create the system? So you need to have an object for each student, for example, a student class. And then probably you will have a class that indicates the courses, so that you can indicate that, hey, this student takes this course. So you will add that course object or course class onto your overall design. So determining the classes and objects that are needed for a certain topic is important. You have to clearly understand and identify those, and the boundaries must be known in order to implement it correctly. And the relationship between those entities is also important. So you have to, is it possible to inherit, for example, the previous example I just mentioned with the student and person. The reverse relationship is not possible between a person and a student. So a person may not be always a student. So you cannot use the student class for every person. You shouldn't use. Then this relationship is important. So you have to be careful about the relationships among the classes. Interfaces. So this is also a topic that we will cover. So interface, you will define an interface that is used by programmers. So let's say what this is referring to actually is if you have a method that you would like to, if you define a class for lots of many groups that are working on the same topic, you would like to create an interface that is accessed by all the groups separately in the same manner. For example, let's say there's within the interface you have a method. Let's say I have a method that returns int get result, and then you have int day, and I have int month. For example, in my interface I define this as one of the class's methods, so I define the rest of the class properties as well. However, let's say this is one of those methods that is implemented in. What this interface indicates is that you do not care how this is internally implemented, but what you know is that, hey, it returns me an integer, and then it takes two integer values. So one group may implement it in one way, and another group may implement it in another way. However, at the end, the idea, the result of those two groups should be same, but their implementations doesn't matter, they can be different. So this is called an interface, and again we will go into details and explain how it is defined and how it is used in general object-oriented methodology. So if you remember, we have seen method design and method overloading. What was method overloading? Method overloading. How do I overload a method? What does overloading mean? So normally,
if methods have same syntax, for example, same name and same argument type, this is overloading, method overloading. When we call the methods, program should choose anyone, one of these methods according to their structures.
exactly. So you can have the same method name, such as, let's say, print date. I created for a date object to print me as a void method on the screen the date on a certain format. So this print date could have, let's say, int day, and then int month, and you can have int year. So what basically this does is that it is going to take these three integers and then print it on a certain format. So you can overload this print date method to be again another void method, which is just going to be doing the same exact thing. However, in this case I will take int day, and then instead of int month I will take string month and int year. So this way I overloaded the print date method with an additional print date method. In the Java compiler will select one of these methods according to the signatures. So if you remember, this is the part of the signature. So you have int in this case. However, in this case you have int string int. So if you pass as an argument a string for the month, it is going to select this print date. Otherwise, if all the parameters all the arguments are integer, it's going to select this print date. So it is going to, the Java compiler will select either one of these according to the signature, as again the signature includes these argument variables and also the return parameter and the name. Okay, so if you do not remember what overloading is, you should again go back and review how it is done and implemented. So the idea is to give flexibility for the user to implement the algorithms in different ways. Do we have time? Inheritance, as I just mentioned briefly, inheritance is that you inherit some of the class's properties in another class, hoping that you will be able to use those methods and variables ready on this one. So you do not need to rewrite everything that has been done in this case. For example, let's say you have a method. This was person, if you remember. This was student. And I had a date of birth. Date of birth property of the person class. So if I have another, by using this instance variable, if I have a method that returns me age, right, which is just going to subtract the date of birth from the current year, and it's going to return me the age, I can use that method directly for the student as well. So I don't need to redeclare, redefine, and re-implement all these efforts on person on this one. So this is inheritance. Student class inherits all the properties and utilities you have in person class. Okay. And we have class hierarchy. So by using this, let's say you have from student, you can have two additional classes that you define, right? For example, I have a grad student as another class, and then I have undergrad student that I'm creating from the student class. So by using these hierarchies, you can generate a class hierarchy, and this is really useful because you do not rewrite everything for the undergrad student. You use just the properties of student, and those use the properties of the person. Okay, so at the end you generate a hierarchy. In your program, you're supposed to design such a good code that implements such behaviors, right? So you have objects that form hierarchies, and you reuse every bit of information you had before. We will deal with overriding versus overloading, how it is implemented. Protected super, again, these are keywords that are used in Java for identifiers. We will see that, and also we will just touch base on polymorphism, which is just going to be briefly introducing the matter to you, nothing more than that. Okay, so also in terms of implementations, what we are going to cover is that we will see sorting algorithms. So in CS 101, if you remember, you have seen insertion sort, right? We will see selection sort. What are the other sorts? Have you heard any other sorts? Bubble sort. Anything else? Quick sort, merge sort, and many others. You can name many other sorts, odd even sort, and there are different algorithms for different cases, and they have pros and cons. And this is a really big area, but we will see some of those examples and compare one to another. If you would like to, you probably will need to deal with them in the future. If you're a CS major, definitely. However, if you are other majors, you will also may also need to deal with those. And we will see search in linear and binary forms. For example, what do I mean by linear search? Obviously, you go linearly, right? If it's a linear search, let's say I have an array A that has certain entries in it, and I'm looking for a certain value. I'm going to search for it. If it is not sorted, how can you search it linearly? If this array is not sorted, what I will do is I will start from the first entry, compare whether the item I'm searching is found here, and if not, I will continue with the next one until all the way to the end, right? So that's basically what you would do if the array is not sorted. However, if it is sorted, how can you check whether whether for a value you are searching for is in this array? So let's say I have an array that is composed of let's say 8 entries: 3, 5, 7, 9, 11, 13, 15, how many I have now? One more. 19. And I'm searching for the value, let's say 15. Does it exist in my list or not? Since this is sorted, how would you go with this? Again, it is sorted. It has to be sorted in order to apply this. How would you go? The best solution would be, actually this is in a sense a binary search. So you divide it into 2 halves, right? And check, for example, the entry 9 here. If it is greater than 9, it must be here. If it is less than, it must be there. So you compare 15 with 9. You see that it is larger. So I do not need to care about this part. Then I will only consider this portion. So I'm going to divide it again into 2 halves. So I'm done with this part. Now I will check whether this is greater than 13 or not. Since it is greater than 13, I will omit this part and also divide this here. And then I will check this one, 15. It's same exact thing. So I found it to be there, and that's what you will return at the end, right? So this is called binary search. Every time you divide your search space into 2 halves and look for the value there. Also, this is implemented in other forms. Just to give you an idea, so let's say I have this implemented in a tree structure. This is the same exact thing, but rather you have a tree structure implemented here. So whenever you have an entry here, let's say I have 10 here, all the entries that are greater than this 10 will be on the right hand side. All the entries that are less than 10 will be on the left hand side. So I will have, let's say, 13 here. So all the greater ones from 13 will be on the right hand side. So 15, 17, and then I have, let's say, 14, and so on. So whenever you look for an element, so you go check with the root and decide accordingly. Go either way, left or right. Okay, so this is also the same thing implemented as a tree instead of a linear array. Okay, so this is called binary search. Instead of here, if you remember, we have found 15 in how many trials? So I tried this one first, and then I tried this, and the next thing I checked is this one, so I found it in the third trial. However, if you had done a linear search, you would have checked 1, 2, 3, 4, 5, 6, and the seventh one will return you the result. But again, the catch is that you have to have this whole array sorted in order to be able to do this and implement this. And exceptions. So what happens if somehow your program gives an exception? It's not exactly an error, but rather a state which you normally don't expect, but if it happens, you would like to take care of it somehow. For example, if you divide by a 0 and you would like to catch that as an exception, then you can do that. Instead of giving the program an error, you would like it to catch this exception and behave accordingly. We will see how this is done, and this is usually done using the finally and throw statements in Java. You will see the details of that as we go in the class. Recursion is also important topic, and sometimes not really understood by the students. So I would strongly recommend you to pay attention to this part, because you will see exam questions coming from this part, and it's really useful for your future as well. So you need to understand recursive thinking and how to write recursive programs, and also we will go into indirect recursion. Do you know what recursion means? Recursion means the method calls itself over and over. So let's say I have a factorial method. So this is the most famous example for this kind of recursion implementation. So let's say I'm writing in factorial method which returns me an integer and then takes an integer n. So what is the result that I need to return in this factorial if I would like to call itself again? So I will return, what am I going to return? I will multiply n with, so I will call factorial with n minus 1, right? So every time if I call it with factorial 5, it's going to call 5 times factorial 4, and then, so you will have factorial. Whenever you call this, what's going to happen is that this is going to be equal to factorial 4, and then this is going to be equal to 4 times factorial 3, right? And this will continue like that until when? According to this code, until when?
0.
Does it say anything about 0? No. So it's going to go forever according to this code, right? It is an infinitely many calls that you call here. So what you have to do is you have to have a stopping condition where you check for n if n is greater than 0, you will call this. Otherwise, you will just return. What are you going to return? You don't need to return anything. Okay. Also, recursion is used for graphical expressions, which we will see in graphics part of the course. And we will deal with abstract data types in the course as well. So which are going to be queues, stacks, and trees. These are brief introduction to the concept, and you will see details of this in CS 201. If you're going to take it if you're a CS major, you will see lots of details of these queues, stacks, and trees. And these are the basic programming, implementation details. So you should know them really well. If you're going to be a CS major, I strongly recommend you to read on those as well. Time? So in each chapter of the book we have, during the last part of the sections, there are individual subsections that are related to GUI. What does GUI stand for? Graphical user interface. Part of the course will be there, so we will be dealing with GUI stuff in that part, and it is actually a good experience for you too, because you will be able to write your program in an elegant manner, and the user, whoever uses your program, will be able to, have a nice view of the code that you're trying to achieve. Instead of a black screen with, enter this value, enter that value, you will have a graphical representation of what you're trying to do, and that's going to give you a lot of power to implement different things. So we will see how to use these components and how to interface them, how to lay out them. For example, we will define a frame. In the graphical user interface part, we will define a frame which we will put things onto it. So we will have a frame, and then we will have, let's say, 2 panes. We will see what panes mean. And we will add these 2 panes, and on top of these panes we will, for example, add a button, here a button and a form, and so on. So you can define hierarchies in the layout in GUI and implement them by using the Java GUI as we go with. So you can define and design polygons and polylines. So let's say you want to draw a rectangle, draw a ellipse, or draw a circle, things like those. You can do that by the GUI properties of the Java, which is already implemented. Events, such as, let's say, on the button, the user clicked the left mouse button, what is going to happen? So you would like to, let's say, execute a certain task, then you will detect that event. On mouse left click, for example, do this. Okay? So you will all be able to do that when we cover that portion. Event adapter classes, how does events adapt to the situations? And we have a timer class that we are going to deal with. Sliders, split panes. These are again components that you can use as GUI components. So combo boxes, and also recursion in graphics. For example, in one of the examples we are going to use recursion to create a snowflake. So if you consider a snow shape, right? If you go into low details, you can achieve that by really calling the recursive method and implement it. So we will see how we are going to use recursion in the graphical user interface components. Okay, so let's give a break here, and then I will continue from this point on.